Hi, testing. Can everyone hear me?
Yep, I hear you loud and clear.
All right. Okay, in that case, I will begin.
Oh, wait, we need to control the slides.
Can you control it? Oh,
Do I have to request remote? Okay, yeah.
got it? All right. Okay, good morning, everyone. My name is Chris, and together with me are my group mates from Team Teknologist, Navid, Erwin, Joel, and Jun Won. And we are here to present our Tech for Good project on sorry, we're here to present our Tech for Good project. And we'll move on to the next slide where I'll talk about the problem statement. So the visually impaired, they can benefit from having a light to carry around with them, alerting others of their presence. However, here is the problem. The visually impaired user does not have information about their light. Is the light on? How much battery is remaining? What is needed for this problem is a low-cost light equipped with audible feedback for powering on off and the alerts when the battery is low. Ideally, this light should also be easily attached to another object or worn on the body, and the light should be cheap as well. Junwon?
So to conduct our project, we partner with Singapore Association of the Visually Handicapped, or SAVH. SAVH is a national voluntary welfare organization that serves and provides comprehensive rehabilitation services to the visually impaired. To further assist us on this project, we have Mr. Winston Woon. Mr. Woon helped us by providing us with the feedback on our prototype design and its functionality. Next slide. So the target users of the project are the visually impaired who can benefit from carrying around the safety light outside. But as previously mentioned, the current solutions are not able to alert the users on whether the light is on and off or its battery levels. Next.
Okay, so here's a picture of our product, which we call the highlight. So we use 3D printing with PLA plastic, which allows us to rapidly iterate on the design. So this is just for the prototype. So we also have a modular base at the bottom, which allows different mounting options to be designed and adapted onto the product. Some ideas that we came up with for the mounts were the carabiner mount for a bag, a wristband mount for the hand, a walking stick mount, and a shirt clip mount, so that it can be clipped onto the shirt. So, and there's the possibility of many other mounts to be designed and adapted for this product as well. So the features that are included in our product include a buzzer to let the user know when the light is being turned on and off, and also for the readout of the battery level. There's also a pressable button on the side, which can be held down for a few seconds to receive a battery readout from the buzzer in the form of a number of beeps, with 5 beeps indicating full charge and reducing by 1 beep with every 20% charge that is lost. There is also a switch on the side that controls the LED and turns it on and off, and also plays the corresponding tone to let the user know that it's being turned on and off. And lastly, there is the modular base, which locks onto the light with a screw-in mechanism for easy replacement. I'll now pass to my teammate, Joel.
All right, so on to the electronics. So for the power, as a power source, we use two CR2032 cell batteries. These are easily available in supermarkets and it can be easily obtained to replace the batteries. The battery life on as we will explain later can be estimated to be about 1 month. So, and following that, we have an LED, which are not only cheap but also very bright and also consume very little power. As the brains of the highlight, we have an Arduino Nano, and for the sound feedback, we use a buzzer, and for user input, we have a button and a switch. So we would like to share a quick demo video with you now. Right, so this is our carabiner mount, and as you can see, there is a carabiner mounted to it, and the primary idea of this mount is to be mounted on a bag. So we will now be turning on the light, and now we will be checking the battery level. And now we'll be turning off the light. So for every action that the user does, there will be a sound input. we are now showcasing the modular removable base. So it is a very easy to use mounting system, which can be easily screwed on and off by our target users. And it's also very so as Navid has mentioned earlier, it's also a very modular design that can be adapted to various use cases. For the dimensions of this object, for our product, it's about 60 mm. It's a 60 mm square and has a total weight of about 7.2 grams, which we find to be a very good weight and size for our target users. So now I'll be passing on to Owen to continue.
Okay, so now we move on to the challenge phase. Firstly, our goal of the project was to make it cheap as well as light, and as well as the light to be in a small form factor. So we looked at getting a off-brand Arduino because of the cost of it. It costs less than a genuine Arduino, as well as the size. The one pictured here is actually smaller than an Arduino Pro Macro, which is already the smallest genuine Arduino. So because of its size, we choose to use it. However, there was difficulty in getting this Arduino mentioned to interface correctly with the button. It didn't register the button input correctly. And so we had to swap back to the genuine Arduino Nano that we use in our final prototype. Next, COVID SMM measures made the assembly of this prototype quite difficult, as only one person had the chance to work on it at a time. So for example, I worked on the initial assembly and printing of the enclosure. However, I couldn't get the button to work correctly, so I had to pass it on to Joel, who then installed the Arduino Nano into it and had the prototype work. So if the SMM measures weren't there, we could have actually worked on it together and completed it within a shorter time period. And lastly, because we use the Nano, the battery life is shorter. So our initial Arduino that we wanted to use had a lower battery consumption than the current Nano, and that would lower our battery life. But we have a solution for that, which is to use the low power library for the Arduino, which is actually code that makes the Arduino run using less power. Well, yeah. And how we can improve this in the future? So firstly, we can use injection molding. Navid mentioned that we use 3D printing to print the enclosure, and that takes a lot of time, as well as it's slightly more expensive than injection molding, as well as less precise because the printer has its own set of errors in the dimensions. And with injection molding, we can overcome these difficulties. Next, we could have used a custom printed circuit board to integrate all the electronics together and reduce the actual size. So what we did in the prototype, we used a prototyping board and soldered all the components onto it individually, and that takes up quite a lot of space. That's why our prototype was quite big. So using a PCB, we could actually decrease the size of our final product, and that would make it more convenient for the end users to use. Yeah, thank you for listening to our presentation.
Thank you, Team Technologist. That sure sounds like a lot of technical work, and definitely it has, with the COVID measures, it made it really hard. But seems like your team has made it through. Perhaps the first question I would like to ask the team is, why did the team choose the battery solution that you have mentioned? Why cell batteries over perhaps lithium-ion or even lithium polymer batteries?
Our general idea for this is that we wanted that our end users to have a very easily available battery solution. So rather than going through the hassle of adding a charging board inside, which would also increase the size and the weight of the overall product, we decided that if we were to use disposable and cheap and light batteries, we would be able to lower not only the cost, but also the usability of it. Yeah.
And also to add on, cell batteries are light, so compared to lithium-ion batteries, and yeah, and that is lighter, so the users will have a easier time using it. Since it's mounted on the shirt and the wrist, having it light will make it easier to attach and less troublesome for the users.
All right, yeah, that sure sounds like something you have considered. And since this is now sort of a follow-up question, And since this is then a battery that has to change, perhaps let's say with your expected battery lifespan is around 1 month, how would the user then change the battery? Would the user change themselves, or would they bring it to someone to change for them? Because I do foresee perhaps the battery change might be a hassle, since cell batteries are usually quite hard to mount. Yeah.
Like for our current solution in the prototype, it's the bottom of the thing actually comes off and it's currently screwed in with screws. So we do foresee that that may be a bit troublesome for the visually impaired to use. So we were thinking of also like trying other designs such as like a snap-on mechanism so that it's easier to be used by the visually impaired. So there's no screws or any other things involved. Yeah.
All right. Let's hope to see perhaps the next prototype, and if let's say the team does roll out, do let us know. All right. Thank you very much to all the teams for their wonderful presentation. And